How many times have you tried to implement professional CAD systems in your projects? Usually for small and medium-sized businesses, this requires significant time, efforts, and investments. In this video, I'm going to share a simple approach to creating schematics, specifications, and other reports using Python macros. All you need is AutoCAD, Excel, and a few simple rules to get started. This method can be used in different areas, but I'll demonstrate this using a basic electrical seal-in circuit as an example. First, you'll need to set up two folders wherever it's convenient for you. The first one is your project folder. The second one contains the executable files in an Excel database that you'll fill in yourself. Let's open the test file and start building part of the schematic. First, we are using a drag and drop approach to place components onto the drawing from the Tool Palettes tab. This tab can hold an unlimited number of blocks, primitives, or commands. These items are stored in a separate file, so they don't take up space in your current drawing. AutoCAD just references them by path. You can save components from my library into the tool palettes or create your own. Keep in mind, by default, these macros only process text objects. That means only text objects will be used when generating reports. So if all you need is to calculate the cost of a product or send a component list to a supplier, you don't actually need to place all the graphical elements in the drawing to get the results. To save your time, I won't be adding component tags, connected cables, or comments to the schematic, because right now, my goal is just to show the basic idea behind this approach. I'll show how to automate all that in a separate video. So give me a few seconds to finish this part of the schematic. Next, we need to number the control wires. If needed, you can use formulas to link wire numbers to the connected components, creating a labeling system that works best for you. But for now, just to keep things simple, I'll number them from 1 to n, where n is the last component. We can update the equipment ratings now to reflect the actual specs used in the project. Let's add a small comment to one of the connected devices, just to show that you can number any object in the drawing however you like. So, go ahead and run the first macro, number, from the executables folder. If everything goes well, you should see this window. When the program completes, all components in the schematic will be automatically numbered. Next, we'll look at how to create a template for future projects. First, select part or all of the sheet and copy it. Then open another .dwg file where we'll save our templates. Paste the copied part of the schematic there. Save this template as a block. Then add that block to the tool palette. That's how it gets there. After that, we can use this block in any other drawings, including our test file. Let's run the number macro one more time to update the labeling. After a few seconds, you'll see that all the components have been numbered. At this point, we're ready to create the bill of materials based on our drawing. Let's run the specification macro. Right now, user interaction happens through the console. For more advanced solutions, it's possible to create an app interface to make the interaction more user-friendly. So after a couple of seconds, we have a BOM file ready in the project folder. The file contains a list of all the components. If that's enough for your situation, you can now close the program. Otherwise, type Y for yes to start selecting components from the database. After that, the program looks for a file containing the word database in the executables folder and uses it to find matches for each component. If there are no matches, the program will ask whether you want to enter the data manually for a new component or look through similar objects. Now you can go back to the schematic, check if any of the suggested components fit, or take a step back in the program. After selecting all the components, the program will prompt you to choose an enclosure for the control cabinet. To make an accurate choice, we'll create a 2D view of the cabinet's mounting panel. Option 1. Here we set the path to the directory where the 2D component views are stored. After all components have been placed on the drawing, the program will ask you to select an enclosure. At this stage, we will not detail the entire control cabinet layout. We'll only verify that the selected size is suitable. Let's go back to the program and select the appropriate cabinet size. The specification file is generated in the project folder. It can be imported into the .dwg drawing or used independently, depending on your needs. All right, time to explain how this works and how you can set up this process in a short amount of time. Let's open a new drawing, insert a few different components, and take a look at what their labels are made of. Pay attention to the layer names. They're the key to how information is collected from the drawing and turned into reports. The easiest way to create a new component is to take a similar one and simply adjust the layer names. Layer naming is simple. Let's break it down. A stands for the main letter code of the component. B indicates what the entry refers to, whether it's a label for the main component, an accessory, a description, or a type reference. Note that these two, A and B, are the core parts. They're outlined in a frame and are required for generating the bill of materials. The rest, C, D, E, and F, are optional codes. C is used for components labeled in a distributed, split way. D controls whether the component should be included in the BOM. E defines whether the component should be numbered. F is used for components that should be listed in the BOM but don't have a letter code, like DIN rails or wire terminals. And finally, let's take a look at the database file. All you need to do is fill in the rows for your components. The blue columns are used to match data from the drawing. The orange column is optional. It's just an example showing how you can add your own details for each component, like price, stock levels, supplier, lead times, and so on. As a result, I have summarized the advantages and disadvantages of this approach. Feel free to pause the video and take a look if you're interested. All the information, available code, step-by-step instructions, a sample library, and my contacts can be found in the description of this video. Thank you for watching, and see you in the next videos.